The other way to load related data after the fact is what's called lazy loading. Like the explicit loading, it lets you get related data for objects that are already in memory. But lazy loading does it on the fly. I'm personally not a big fan of lazy loading because it's so easy to accidentally abuse it and create performance problems or get unexpected results. Fortunately, lazy loading is disabled by default in EF Core. That's because it's so easy to trigger that the EF Core team wants to make sure that you've been very explicit about enabling it. Once it's enabled, lazy loading works implicitly, and it's really easy to use. It works without the ceremony of coding up the explicit loading. All you have to do is make some reference to that navigation from the existing object. And as long as you've got a DB context in scope, that will immediately trigger the lazy loading, just like when we called the load method on the entry. So how do you enable it? First, every single navigation property in the model has to be marked virtual. Every single one. Second, you need to add the Microsoft Entity Framework Proxies package to your project. And third, in the DB context class, you need to tell the options builder to use lazy loading proxies. Here's the code to do that. I don't want to spend a lot of time on this topic, but I do want to warn you about some of the common problems you could run into. First, I should at least say something nice about it. As I already said, it does make it so easy to load data once you've got everything set up. Now let's look at some of the common mistakes people make with lazy loading. First is when using an aggregate method such as count on the reference property, EF Core won't just go get the count, it will send SQL to retrieve all of the complete book objects for that author, then it will add each of those to the change tracker, and then, in memory, it will apply the count method and give you the result. If you're not profiling the SQL, you might never know about this until that author has written 2,000 books and the app gets really slow. Another common mistake happens with data binding. For example, a developer will retrieve a list of authors in a query and bind them to a data grid. And then when setting the properties of that grid's columns, maybe set one of them to the author's books property, perhaps again using books.count. And doing that knowing that lazy loading will go ahead and take care of that. But this causes a performance issue because the lazy load happens for each of the rows. This is referred to as an n+1 query, when one query triggers a number of other queries. And again, this is something you might not notice if you're not profiling your database, and then eventually performance gets really bad. The last gotcha I want to point out is that lazy loading is dependent on there being a DB context in scope to do that loading for you. So if you've used a context to query authors and then disposed the context and then made a reference to the author's books, there's no context there to do the job. So in response, you'll get 0 books and might be fooled into thinking that that author has not written any books, or that customer has not added any items to their shopping cart. So you can see why I prefer to steer new users of EF Core away from lazy loading until they really spend some time understanding how it works, because there are so many ways to accidentally misuse it. With more expertise, it can be a really valuable tool in your arsenal. So far, the focus for the retrieval has been on pulling back related objects. You can also take advantage of related data for querying, even if you don't want to retrieve those related objects. Here's a simple example of that where I want to retrieve any author that has published a book since 2015. I don't need the books, I just want to see those newer authors. So I'm able to navigate through the relationship in my where predicate, then do a subquery of the author's books where I'm determining if any of their books have a published date whose year is greater than or equal to 2015. Entity Framework and the SQL Server Provider transform that link query into this SQL where exists query. It's only selecting the properties that make up the author, but in the where predicate, it is looking at the author's books. You can see in the results that I just got back the 2 authors, and these are the authors who happen to have newer books. But I've only gotten the authors. Notice that their books collections are empty because that's all I asked for. I used a where link method and an any method in my subquery, but you can use all sorts of link methods to compose this type of query, where the related data is used to filter or sort the main object. Depending on how creative you need to get, it's always good to profile the resulting queries in the database, just in case it can be written more efficiently with a procedure or a view. We've looked at adding graphs or adding data to existing graphs already. But what about updating data that's part of a graph? Like the additions, you need to be aware that things will work differently when the data is being tracked as the changes are being made, versus if it's disconnected and the DB context begins tracking the object's state after the changes have been made. Let's first look at making changes to a graph of objects while EF-Core is tracking them. Instead of actually saving the data and looking at the SQL, I'm going to just use the Change Tracker's debug view to show you how EF-Core is interpreting the state of some graphs as I'm making changes. Here's a method where I've used include to query for a single author and then eager load that author's books. And I know I'm using an author that happens to have 2 books in the database. Then I drill into the first book in the collection, modify its base price, and call Change Tracker Detect Changes. Remember that Detect Changes causes the Change Tracker to update its knowledge of the state of all the objects that it's tracking. And I'm calling it directly since I'm not using Save Changes, which would otherwise have done that for me. After that, I'm capturing the Change Tracker's debug view into a variable. And when I run this method and look at the debug view, the state of that book is modified, and the author and the other book are unchanged. So since the context continued tracking those objects, it recognized exactly what had changed. Because this one-to-many relationship is using the default mappings where the book must have an author, I could also easily delete any of the books while the change tracker's in scope. I've added this line of code where I'm removing the book from the author's books property, not doing anything with Entity Framework Core. And looking at the change tracker when this is run, you can see that the state of that book is marked as deleted. We'll be looking more at removing related data a little later in this module. So as usual, things are pretty simple when the change tracker is in scope and watching what's happening with the objects. Now let's look at a scenario where the change tracker doesn't know about the object's history. Again, I'm retrieving that same graph and editing the book's price again. Next, I'm creating a second instance of the pub context to emulate that disconnected scenario. I'm using the book's dbset update method to tell this new context to start tracking that book from within the graph and mark it as modified. After that, we'll check the debug view again. When I run this method, look at this detail. Something really strange happened. All of the objects in the graph are marked as modified, not just that book. What happened is that the book is part of a graph, and when I called update, the update logic was applied to every object in the graph, and that is expected behavior for EF-Core. Well, it's expected if you're aware of how EF-Core works. The only time that update wouldn't get applied to every single object in the graph is for any items in the graph that are new and don't yet have a key value. In fact, objects with no key value, no matter if you use the add method, the update method, or the attach method, will always be marked added. That's a really good thing to be aware of. But otherwise, if you use the update method and you pass in a graph, you're telling it to update the graph. We do have other ways to start tracking objects and anything that's attached to them. For example, the dbset attach method. If I had used that instead of update, all of the objects in that graph would get tracked, but they'd be marked as unchanged, even the one that I modified, because the context has no idea that I modified it. I just said, hey, here are a bunch of objects. So using attach isn't going to help us either. So how do we get around the side effect of EF-Core's behavior? It's not an easy coding task to separate the quote from that graph. But lucky for us, EF Core knows how to do that. We just have to use a different path. Instead of using the dbset add or update or remove method, you can use the dbcontext entry method, which gives you a lot more control. And if you're coming from EF6, take note because this behavior is different than it used to be. In EF Core, entry will focus specifically on the entry that you pass in. So I can pass the book object into the entry method and then use the entry's state property to set the state of that entry to modified, which is one of the entity state enums. In this case, I do want to call save changes because there's one more thing I want you to see. Now, when I'm using the entry method to track the book and set its state to modified, the change tracker is only tracking the book. Now let's see what happens when I call save changes. As expected, it only sends an update command to the database for the book. But notice that it's updating all of the columns except for book ID. And you learned about this earlier in the course when we used update on the authors. The update method has no indication of which property got updated, so it defaults to updating all of them, except for the key. There's a lot more that you can do with the dbcontext entry method, but for this fundamentals course, I'm going to leave it at that.